Hi guys, welcome to Linux our YouTube channel. My name is Ram Mishra and I'm your online instructor. So what's in this video? In this video we will talk about how to debug and troubleshoot bash scripts. But before start the lab session we need to understand few points which is the importance of debugging in shell script and how it's useful in shell scripting. When things don't go according to the plan, you need to determine what exactly causes the script to fail. So debugging and troubleshooting are essential skills for any bash scripter. While bash script can be incredibly powerful, they can also be prone to error and unexpected behavior. In this demo session, we will discuss some tips and techniques for debugging and troubleshooting bash script. So let's do the lab session and see how it's useful for us, right? So here you can see I'm on my Linux terminal. Let me show you the OS release version first of all. So etc Red Hat release. This is RHEL 9.3. So let's start the first case, which is enabling verbose mode with -v flag. So one of the easiest approach to debug the bash script is using -v option, also known as verbose. The option can be added with the shebang or explicitly put with the script file name while executing it. The verbose option will execute and print every line of the code as the process by the interpreter. To demonstrate this, let's create a simple script. So first of all, we create a text file using text editor in Linux. In this case, I'm using vim text editor, but you can go with anyone. I'll make a file demo.sh and let me copy the code from my notepad. Okay, now let me try to explain this code. So basically this script checks whether or not the number entered as input is positive. So let me explain the code. The first line is shebang line. This tells the operating system to use the bash shell to execute the script. From second line, read command prompt the user to input, and -p option allow you to display a prompt message. Enter the input here, right? The value store the user's input in a variable named value. From the next line, my value is equal to 0. So this set a variable my value to 0. It's being used as a reference to check if the entered number is greater than 0 or not. Then from the next line, if condition start, if dollar value greater than my value. So here if value check if value is greater than my value, which is 0, and gt stand for greater than. This only works for integers, and if the condition is true, the entered value is greater than 0, then it prints this is the positive number, right? And if it is not true, then what happened? Then we got another result, this is not a positive number, and finally close it. So let's execute our script with -v flag and see what happened. I'll save and quit. I run the command bash -v and demo.sh. The moment I press enter the input, I set 12. You can notice this is a positive number and I see entire verbosity here, right? So you can notice it prints line of script on the terminal before it process, and finally we got the result as per the condition met. If I run one more time, this time I said -2. This is not a positive number. So this is how you can enable the verbosity mode. Let's go another case, which is syntax checking. Very important, using no exe mode. Sometimes your script might have syntax error that prevent execution. Syntax error are one of the primary cases of bugs. For syntax check, we use no exe, no execution mode. The option used for no exe mode is -n. It will only display the syntax error of the code instead of executing it. This is much safer approach to debugging the code. This will be useful in the situation where we want to validate the script prior to its execution. So if so, we can use no exe mode using -n option. So as a result, bash will read the commands but not execute them. So let's execute our demo.script in no exe mode. So I'll go bash -n demo.sh this time. You notice this pursued a blank output since there is a no syntax error. Now we will modify our script a bit and remove something from there. I'll open demo.sh. I suppose I commit out line number 5, which is done. I'll save and quit. Now we will validate syntax with -n option one more time and see what happened. Look at, I got something here. So as we expected, it threw an error since we missed then statement in the if condition. So this is how you can use no-exe mode to check syntax error, right? Let me go back and correct my script again. Remove, save and quit. So this is important, use -n. Let's go another case, which is debugging using Xtrace mode. One of the fastest method to debug a bash script is by enabling debug mode. This print each command before execution and helping you trace the issues. Execution trace, also known as Xtrace, is a smart and useful debugging option, especially to trace logical errors. Logical errors are usually associated with the variables and command to check the state of the variable during the execution of the script. So we can use -x option. So let's again run demo.sh file with -x session and see what happens. So I use one more option -x and I press enter. So let me drop the value, enter the value as 12, and I got the result. This is the positive number. So here we can see expanded version of variable on standard output before execution. It's important to note that the line preceded by plus sign, all lines are plus sign plus plus plus, are generated by the Xtrace mode. So this helps you see exactly what's happening at each stage or each step. So let's go another case, which is identifying unset variable. So making a typo while writing a code is very common. Often you mistake a variable which does not let the code execute. So to identify such an error, we can use -u option. So let me modify my entire code. Let me go one more small script. Let me go this one. I'll copy and paste and save it. So this is a small script for addition result point of view. Here the first line is shebang line. Then from the next line, with the help of read command, prompt the user to enter the first number first of all. Type the first number and hold it and store in the input variable result first. Then second time, type second number, hold it in second. Right. Then from the next line, intents this one, sum is equal to calculate the sum of the first and second. Dollar double round bracket is used for arithmetic expressions in bash. And finally, at the last line, we print the result of addition via echoing them. Sum of the both value is $sum. So let's execute the script and see what happens. I'll save and quit. I run the command again, bash demo.sh. First number 12, second number say 2, answer should be 14. Sum of the both value is 12, it's not 14. So you can notice there is an issue. The script executed successfully, but the output logically incorrect. Well, now execute the script again with -u option and see what happened. So this time I run the same script with -u option. Enter the first number 12, enter the second number 2, and now you can see I got error, line number 4, unbound variable this. So here you can see the script failed to execute since the variable, let me open the file. Look at the variable name. Here's the typo error, am I right? second. So since the variable second is not defined, we had mistakenly typed second as second while calculating the sum. So let me go and set it second, save and quit. Now let me run one more time, 12 and 2, and finally got the result. This is how it's very useful if you want to check the variable point of view, result at the check on the base of variable point of view, right? So this is, you can go with -u option. Let's go another case, which is debugging specific part of the script. So we know very well Xtrace mode process every line of the code and give the output. But however, finding errors in a large code will be time consuming. If we already know which part is potentially causing the error, luckily Xtrace also also allow you to debug a specific portion of the code which can be accomplished by using set command. So you can use set hyphen minus x at the beginning of the portion that need to be debugged and set plus x at the end, right? So let me modify my script again. I make it blank. I'll go here and this time I follow the same script, but this time I want to check particular section, not whole. I save it. So this is the same script we used earlier. I just add set x to debugging a specific part of the script, not the whole one. So look at the line number 4. Turn on debug mode. I use set hyphen x. And look at that line number 12. Turn off the debug mode. Set plus x. And finally, I give the message echo script ended. The rest of the things are same, which I have already explained, right? So let's validate it and run it one more time. So I'll save and quit. I run bash hyphen uh, let it go and simply run the entries, right? So I don't need X here. I can directly type demo.sh. The moment I press enter the output. I said 12, and you can notice it started from here to here. Look at the plus sign, here to here only, right? Not on script ended, right? So this means what happened? It looks less disarray, right? So set X enable the debugging in bash and set plus X disable the debugging. So here is the part. So you can notice debugging start from here, right? If condition, so you can notice it's there. Then echo the result. Then finally set plus X and close it. So this is how you can check particular portion. Let's go another case which is an exist on error condition for the script. Suppose we have a bash script that runs several commands and we want to ensure that it exists immediately if any command fails. So we can run the script using -e flag. So this causes the script to exist immediately if any command fails. This can help you identify errors more quickly. So let me make it blank again. I'll open this demo.sh and let it be go. Write down a simple command like date command. Here you can notice, oops, percentage slash bin bash. Okay, so look at the code bin bash date cal dir and host 1. So you can see, let me try to run it first of all, right? See what happened here. Even you can notice dir1 command is wrong, but let's try to run it. See what happened. Bash demo.sh. So you can see script run, but we got error dir1 command not found. Here command not found, but after that we got another result from my host name command. This is I don't want. I want to stop this behavior. My requirement is that I want script to exist immediately if any command got fails. So I use -e and now I press enter. So here you can see script exists immediately as soon as he got non-zero exit code from dir1 command output, right? Exist here. This time I'm not getting the result of host name. So this is how you can use -e option. So this is, I hope you understand the idea which I'm trying to explain, right? Let's go to the final case, which is very important, how to redirect debug report to a file. So saving a debug report of a bash script to a file can be handy in many situations. It is a bit tricky because to redirect debug report to a file, we use some special variables. So let's implement on the demo.sh file. I'll I'll go to the entire code and let me copy my entire script one more time. Okay, I'll save and quit. Okay, so now let me explain this entire script. This script basically runs a simple numeric compression between two input, and meanwhile all executed command with line number are saved to debug report log file, right? For debugging purpose. The first line is shebang line, tells the system to use bash shell to execute the script. If I go on the top, this one. Then the next line is basically open debug log on file descriptor 5 fd5 exec5 greater than debug underscore report dot log. The exec command is redirecting everything happening in the shell to a file debug underscore report dot log. This redirect file descriptor 5 to write a debug underscore report dot log. This allows us to send custom output like debug trace to a file rather than disarrays the terminal. Then from the next line, sending tracing output to the fd5. So we have bash xtrace hyphen fd5, bash support tracing via set hyphen x. So this line redirect all trace output to the fd5, which is going to the file debug underscore report dot log. So question is, what is fd5 here? The fd5 is an extra, or you can say custom file descriptor then that the script is used to send debug output. File descriptor 3 and above are available for custom use by script or programs. In this case, the script does exe5 greater than debug underscore report dot log. This means open the file debug underscore report dot log for writing and assigning it to the file descriptor 5. Then bash xtrace fd is equal to 5. It's a particular bash variable and cannot be used in any other shell. It needs to be assigned a valid file descriptor, and bash will write the xtrace output to the particular file, which is debug report.log. Then so basically it tells the bash send all the command trace output to the fd5 instead of default. So fd5 is just like as a common custom, you can say, file descriptor used in the script to capture the debug output into the file, which is debug underscore report dot log, without cluttering the terminal. Then from the next line, customize the trace prompt. Here ps4 is equal to $line number. It's also a bash variable used to print the line number while debugging using xtrace mode. The default value of ps4 is the plus sign. It set the prompt that appears in the front of each line in the trace log file. The line number is bash variable that shows the line current line number in the script. Then I enable the tracing set hyphen x. Enable execution tracing, so every command that is run will be logged to the trace output in a particular file. Then from the next line, using read command from the user to enter the two number and save them into the two variable number 1 and number 2 respectively, right? Then if condition started from here, so compare the number using numerical expressions gt greater than eq equal else less than. Then finally disabling tracing using set plus x. If you go here, we disabled here, and at the last we just use echo script and here. So this above script is generating a log file debug underscore report dot log. To read it, we use simple cat command. So let's run the script and see what happened. So I save the script and I run the bash demo.sh. Enter the first number 12, enter the second number 2. Number 1 is greater than number 2. Script ended here. And we got the result. Let's check the log. So cat, the log file will be debug report.log, and here you can see I got the trace result, right? With line number 11, 12, 13, 14, and whatever is there. So this is how you can redirect a debug report to a particular file. Finally, we are in the conclusion part, which says that you have a good understanding of common shell scripting errors, effective debugging techniques, and solution to troubleshoot and resolve the unexpected output in your shell script. This knowledge will improve your or empower you to write more robust and reliable shell scripts, enhancing your productivity and efficiency in the world of shell scripting. That's all about this demo, dears. Thank you for taking the time with me, and I hope that is had improve your understanding of the topic. Hopefully, you enjoyed and learned new things. Soon, I will come up with another new interesting topic. Till that, keep practicing. If you feel something I have missed or you wanted to know more something else, please reach out through my social media link, which is mentioned in the description. If you like this video, please do not forget to like, share, and subscribe my channel and press the bell icon button for latest update. Thanks for watching. Stay safe and